Hi everyone, I am Upasana Mishra and welcome to my educational channel The Funda. In today's class we will learn another interesting subtopic of the main topic, that is sequence and series, and the subtopic is geometric progression. Okay, so what is the geometric progression? So first we will answer that question. A geometric progression or GP is a sequence for which there exists a constant r such that each term is r times the previous term. Okay, so as we had discussed in Ep, that in an Ep the common difference between any two terms is constant. Okay, the difference between any two terms is constant. So a GP has a similar concept. In a GP, the ratio of any two consecutive terms is constant. That means that how we can get the next term? By multiplying a fixed number, say r, to the previous term. Okay, so let's take an example. So if I write 1, 3, 9, 27, 81, 243. So this whole sequence is a GP. Why is it so? This is because if you see the first and the second term, if we multiply 3 to the first term, that is 1, we will get 3. Again, if we multiply 3 to the second term, we will get 3 into 3, that is 9. Again, if we multiply 3, we will get 27. Similarly, if we multiply 3, we will get 81. And if we will multiply 3, then we will get 243. So each term that we are getting in this GP is just we are multiplying a fixed number, that is here it is 3, to the previous term. So this fixed number that we are multiplying, here we have already told that it is r. This r is also known as the common ratio. Okay, common ratio. As in the in Ep we had discussed that the common difference, that the term d that is added to the each term to get the next term is known as the common difference. Okay, similarly here the thing that is multiplied, the number that is multiplied to each term to get the next term is known as the common ratio. Okay, it's just a name of the fixed number, that is r. So let's do one question. Okay, we have understood the definition of GP, and we have also understood about the common ratio and everything. So let's do a simple question. Okay, so the first question is, the first term of a GP is a, common ratio is r, find the nth term of the GP in terms of a, r and n. Okay, so now you may pause the video and solve this question. Only after solving this question, then only see the solution of this question. Don't be in a hurry to know the solution. Okay, so the answer is, so here we are given that the first term of a GP is a. Okay, and the common ratio is r. We are given the common ratio is r. So from the definition that we just learned a few minutes ago, that in a GP, every term we get the next term by multiplying if the common ratio r to the first term, the previous term. So here the first term is a, so the next term will be a into r, that is ar. The third term will be this term into r, so it will be a r square. Fourth term will be this term into r, so it will be a r cube. Similarly, AR4, dot dot. So this is the first term, this is the second term, this is the third term. Why I am doing this? I am doing this just to get a pattern, so that I can generalize this thing, that for what will be the nth term. Okay, that is why I am writing these things, just to know what is the pattern which it is following. So it is the fourth term, it is the fifth term. So here you can see that for second term I am multiplying the first term into r to the power 2 minus 1. So r can also be written as r to the power 2 minus 1. Similarly, for the third term, I am multiplying the first term a into r to the power 3 minus 1. Okay. Similarly, for fourth term, I am multiplying a into r to the power 4 minus 1, that is 3. So here I have got a pattern. So for the nth term, it will be first term a into r to the power n minus 1. Okay, here you can see for fifth term it is a into r to the power 5 minus 1, that is 4. So here for nth term it will be a into r to the power n minus 1. Simple. So this thing you have to remember, that nth term of a GP, you have to remember that nth term of a GP is a r to the power n minus 1. Okay, this thing you have to always keep in mind. Nth term of a GP is a r to the power n minus 1. Okay, so now we have learnt what is the nth term of a GP. This concept is similar to that of AP. We have learnt what is the nth term of AP. So now we have learnt what is the nth term of a GP. So let's move to the next question. So the next question is, this is question number 2. The first term of GP of positive numbers is 12 and fourth term is 24. Find the common ratio of the GP, find the formula of nth term of GP, find the 10th term of GP. Okay, so we are asked, so you now may pause the video and then look at the solution. First solve this question. Okay, so the answer is the first term of GP of positive numbers is 12. Okay, and fourth term is 24. So we are given that there is a GP and the first term is 12 and the fourth term is 24, and it is given that all are positive numbers. Okay, so let the first we have given the first term is 12. So what will be the next term? So it will be 12 into r. So for the fourth term it will be, the formula is a into r to the power n minus 1. So let the common ratio is r, and fourth term means it is 4 minus 1, that is 3. Okay, so 12r cube is equal to 24. So we have to find the common ratio. Simple, we have just utilize the formula that a r to the power n minus 1 equal to the nth term. So r cube equal to 24 by 2, that is 2, and r equal to 2 to the power 1 by 3. Okay, so we have solved the first question, that is the common ratio of the GP. Find the formula for nth term of GP. Okay, so what will be the formula for nth term of GP? It is a r to the power n minus 1. So here a is 12, the first term, r is 2 to the power 1 by 3. So a r to the power, so this is the answer of B, a r to the power n minus 1. Okay, so this is the formula for nth term of the GP, a r to the power n minus 1. Here r is 2 to the power 1 by 3, a is 12, and n is is nth term, any term of the GP. So now we are asked what is the 10th term of the GP. So 10th term means we have to replace n by 10. Okay, so it will be 12 2 to the power 1 by 3 to the power 10 minus 1. So it will be 12 2 to the power 1 by 3 whole to the power 9. So it will be 12 into 2 to the power 3. This is 8. So it will be 96. Okay. So now we have got all the answers to this question. So let's move to the next question. Okay. So the question is, suppose XYZ is a GP common ratio with common ratio R such that X is not equal to Y. Okay. And if X, 2Y and 3Z is an AP, find the value of R. Okay. So now you may pause the video and solve this question, and then we will look at the solution. Okay. So the answer is, suppose XYZ is a GP and common ratio is R such that X is not equal to Y. Okay. So first let us just forget this line that X is not equal to Y, because we don't know what is X and Y. So first let us not look at this thing. So what is the condition? That X, Y, Z are in GP. X, Y, Z are in GP. So as soon as I see this term that X, Y, Z are in GP, so let the common ratio be R. Okay. If the common ratio is R, then Y will be X into R, because it is the next term of the GP, and Z will be X into R square. Okay. So now we have converted X, Y, Z into X, XR and XR square. Okay. So because these three numbers are in GP. Now we are given that X, 2Y and 3Z are in AP. So in place of Y, I will write XR, because I have already shown here. So X, in place of Y it is XR, so here it is 2, so 2XR, and Z is XR square, so it is 3Z, so 3XR square. It is an AP. It is an AP. So find the value of R. So if these three terms are in AP, then the difference between any two terms will be same. So difference between these two terms and difference between these two terms will be same. So 2XR minus X equal to 3XR square minus 2XR. Okay, this we have written from the definition of AP. Okay, arithmetic progression, that we had discussed in the previous class. So now we will take X common. So it will be 2R minus 1, and from right hand side also we will take X common. So it will be 3R square minus 2R. Now here you can see that X cancels out in this equation. So this will be equal to, so this implies 2R minus 1 equal to 3R square minus 2R. We have to solve for R. Okay. So now we will rearrange this whole equation. So it will be 3R square minus 4R plus 1 equal to 0. Okay. 3R square minus 4R plus 1 equal to 0. So this is a quadratic equation. Okay, we have to solve what is the value of R from this equation. So this is a quadratic equation. So how we are going to solve a quadratic equation? We are going to factorize this thing. Okay, so if you don't know how to solve a quadratic equation, just remember that in the case of a quadratic equation, you have to factorize this whole equation, and you have to write it as a product of two factors. Okay, that is the meaning of factorization. So how I will factorize this whole thing? So think of a number by multiplying, think of two numbers. By multiplying them, you will get 3, this 3 into 1. The coefficient of r square and the last term. So by multiplying those two numbers, you will get 3 into 1, that is 3. And by adding those numbers, you will get minus 4. Okay. Think of two numbers that after multiplying them, you will get 3, and by adding them you will get minus 4. So what are the two numbers? They are minus 3 and minus 1. Minus 3 into minus 1 is 3, and minus 3 plus minus 1 is minus 4. So now we are going to write this term, that minus 4, we will write as minus 3 and minus 1. Okay. So how we are going to write? 3r square minus 4r we will write as minus 3r minus r plus 1 equal to 0. This is the simple way of solving quadratic equation. There are also other ways of solving quadratic equation which we will learn next. Okay, when we will study this chapter, the quadratic equation, we will learn various things about quadratic equation. So till then, just remember that the simplest way to solve the quadratic equation is to factorize the whole equation. And how we are going to factorize? That the second term, that is the coefficient of r or x, that term you have to write as the sum of two numbers, and that two numbers should have a product that is equal to the coefficient of r square and the coefficient of and the last term. Okay, this may sound a little bit confusing at first, but it is very easy subsequently. I will also tell you about a formula how to find the answer, and that will become even easier. So don't be confused. So now we have written this whole equation like this, and now we will take r common from this term. Okay, so we'll take 3r common. So 3r, if we take common, it will be r minus 1, and from this whole thing we will take minus 1 common. Okay, so it will be minus 1 into r minus 1, okay, equal to 0. Now from this whole equation we will take r minus 1 common, this r minus 1. So r minus 1, if I take common, it will be, here it is 3r, here it is minus 1, so it will be 3r minus 1 equal to 0. So now we are given that the product of two numbers is 0, that is r minus 1 into 3r minus 1 is 0. What does it imply? So let's see. So we are given that r minus 1 into 3r minus 1 is equal to 0. So when is the product of two numbers 0? The product of two numbers is 0 when any one of those numbers is 0. So it may be that r minus 1 equal to 0, or it may be 3r minus 1 equal to 0. So r can have a value of 1, or r can have a value of, here by solving this, r is equal to 1 by 3. So now we have got two values of r. Always by solving a quadratic equation you will get two answers. Okay, in linear equation you always get one answer. Like if I say, for example, 3x equal to say 3. So x will be equal to 1. Simple, because this is a linear equation, you will get only one answer. But in quadratic equation, you will get two answers. Okay, we will study in detail all things about the quadratic equation. So don't worry, just see how this question is solved. So now we have got two answers, but both the answers is not acceptable in the case of this question. Both the answers are not acceptable. Okay, how I will know that? So if I will take r equal to 1, okay, if I take r equal to 1, then I have we already know that x, y and z were in a GP. So y equal to xr and z equal to xr square. So if I take the value r equal to 1, then y will be equal to x and z will also be equal to x. But in the question, let me show you the question. So in the question, I had told you that this thing we are not going to see at first, but now we are going to see this whole thing that is written here, that x is not equal to y. Okay, so in the question it is already mentioned that x is not equal to y. So if we will take the value of r as 1, then x will be equal to y, as you can see here. If we will take r as 1, then x will be equal to y, which is not acceptable in this question. Okay, so what is the next value? That is r equal to 1 by 3. So the answer is r equal to 1 by 3. Okay, so the common ratio is 1 by 3. Okay, simple. So let's move to the next question. Okay, the next question is, a sequence of 3 numbers form an AP with first term of 9. If 2 is added to the second term and 20 is added to the third term, then 3 resulting terms form a GP. What is the smallest possible value of the third term of GP? What is the smallest possible value of third term of GP? So this question is a little bit trickier than the first question, but try, just pause the video and think about all that we have learned previously and try hard to solve this question, and then we will see the solution to this question. Okay, so you may pause the video and solve this question. Okay, so the answer to this question is, a sequence of 3 numbers form an AP with first term of 9. Okay, so the first term is 9 and there are 3 numbers that form an AP. So if 3 numbers are in AP, the second term will be 9 plus D. D is the common difference. And the third term will be 9 plus 2D. Okay, this we have learned from the definition of AP, that every term we are adding the common difference D to get the next term. So 9, 9 plus D, 9 plus 2D are in AP. So we are taking these 3 numbers. These 3 unknown numbers is 9, 9 plus D, 9 plus 2D. If 2 is added to the second term and 20 is added to the third term, then the 3 resulting terms form a GP. 2 is added to the second term. This is the second term, and to it 2 is added, so it will be 9 plus D plus 2 will be 11 plus D, and 3 is added to, and 20 is added to the third term, so it will be 9 plus 2D plus 20, it will be 29 plus 2D, and then the 3 resulting terms form a GP. So the first term is 9, we are adding nothing to it. So these 3 numbers these three numbers, it forms a GP as per the question. 9, 11 plus D, 29 plus 2D form a GP. What is the smallest possible value of third term of the GP? So what is the smallest possible value? Smallest value of 29 plus 2D, that we are asked. So how we will find that? So we know that these three numbers are in GP. That means the ratio of these two numbers and the ratio of these two numbers is same. Okay, in a GP, by multiplying a fixed number to this, we are getting this number. So the ratio of these two numbers, and also by multiplying a fixed number to this, we are getting this number. So the ratio of these two numbers, this whole ratios are equal. From the definition we already know that. So 11 plus D by 9, okay, is equal to 29 plus 2D by 11 plus D. Okay, so the ratio of this number and this number, 11 plus D by 9, equal to 29 plus 2D by 11 plus D. Okay, because this is the definition of GP. If you are getting confused how I have written this, then just remember that A, AR, AR square, these three numbers are in GP. We already know, because by multiplying R to the first term, then R to the second term. And so how I am telling that the ratio is same? Because AR by A is equal to the answer. This AR by A is equal to R. And AR square by AR is also equal to R. This is the thing I am writing here, that the second term by first term, AR by A, is equal to the third term by second term, AR square by AR. Okay, this thing only I am writing here. Simple. So now I will cross multiply this whole equation. So 11 plus D whole square equal to 29 plus 2D whole into 9. Okay, so let's now solve this question, this equation. So what we are given, that 11 plus D whole square equal to 9 into 29 plus 2D. So what is the A plus B whole square? If I have given A plus B whole square, that will be equal to the form. This is just a formula. Will be equal to A square plus B square plus 2AB. Okay. So here it will be A square. It is in place of A I will write 11. So it is A square 11 square plus B square, that is D square, plus 2AB. So 2 into 11 into D. So it will be 22D. Okay. Equal to 9 into 29, which is equal to 261 plus 9 into 2D, that is 18D. Okay, so now we have got an equation. So by rearranging it, what will be D square plus 4D minus 140 equal to 0. So again I have got a quadratic equation and I have to solve the value of D. So I have already told you that I will tell a formula how to solve a quadratic equation. So now I am going to tell you the formula. First we knew the trick how to solve a quadratic equation by factorizing it and writing it in terms of two factors, and then by equating each of the factor to 0 and getting two values of two values as answers. Now we will also learn about a formula from which we can also know the two values of the answer. So let ax square plus bx plus c equal to 0. This is a quadratic equation. So the value of x, that is the solution of the equation, is minus b plus minus root over b square minus 4ac by 2a. It may look complicated. Here I am writing plus minus because two values will come. One is minus b plus root b square minus 4ac by 2a whole by 2a. Another answer is minus b minus root b square minus 4ac by 2a. Okay, this is how we are solving quadratic equation. We will, in the chapter of the quadratic equation, we will also derive that how we are getting this complicated equation as the answer. Okay, that is very interesting. That we will learn after I complete this chapter. That is very interesting and you will enjoy a lot quadratic equations and other kind of linear equations. Every equations we will learn. So now let's apply this formula to this equation, that is d square plus 4d minus 140 equal to 0. So it will be minus b. So here b is 4. Okay. So minus b plus minus root over of b square, that is 4 square 16 minus 4 into a. Here is the coefficient of d square. Okay, here a was the coefficient of x square, so here the coefficient of d square is, so here it is 1 minus b plus minus b square minus 4a into c. C here is minus 140. Okay, 140 whole by 2a, 2 into 1, that is 2. So by simplifying this we will get minus 4 plus minus root over of 16 plus this 140 into 4, that is minus 140 into minus 4, it is plus 560 whole by 2. So it is minus 4 plus minus root 576 by 2a. Root over of 576 is 24. Okay, so this will be equal to minus 4 plus minus 24 by 2. So it will be, one value will be 20 by 2 is 10, another value will be minus 28 by 2, it is minus 14. So these are the two values. For solving this kind of questions, if you memorize the values of the squares of numbers from 1 to say 30, if you memorize those values, then calculating the root, here as we have calculated the root of 576, calculating those roots will be very easy for you. Not if you cannot learn up to 30, then just learn up to 25. Okay, what is the square of 24, what is the square of 14, what is the square of 19, just memorize those values. Then while solving the equations involving the roots, you will find it very easy, because you don't have to calculate the root and then you will write. You can just, from the memory you can tell that okay, 576, the root is 24. Okay, so just from the memory you can tell. So now we have got two values of the common difference, that is d. We have got, it is 10 and minus 14. Obviously, as we had discussed in the previous question, both the values will not be acceptable. Okay, in other questions it may be acceptable in some other case, but here it will not be acceptable. So how I will know that? So once you look at the question again, so here it is written, what is the smallest possible, once again, what is the smallest possible value of the third term of GP? Smallest possible value. Now we have got that D has two values, that is 10 and minus 14. Now we have to put those two values of D, that is 10 and minus 14, and then we are going to find out what is the smallest possible value that the third term, that is here we had already written that the question is to find the smallest possible value of 29 plus D. So now we will use both the values of D that we have got, that is 10 and minus 14, and from that we will find which value will give the term 29 plus 2D as smallest. Okay. So now we have to make 29 plus 2D as the smallest. Okay. Our aim is to make 29 plus 2D smallest. First let us try with 10. So by 10 it will be equal to 49. But if I put minus 14, then it will be 29 minus 28, which will be equal to 1. For minus 14, this value will be equal to 1. So obviously 1 is less than 49. So this value minus 14 is the right value. Okay. And what is the value of the third term? The smallest possible value of the third term of the GP is 1. So we have got the answer. Let's check the answer. Let's see what is the GP. We have calculated already. So if D is minus 14, then the AP, the previously that the three terms we had taken. So if D is minus 14, then it will be 9, comma, it is minus 14, then it will be minus 5. Yes, and it will be minus 5 and okay, 1 second. It will be minus 28 plus 9, which is equal to minus 19. Okay. So here it is minus 14. So you can see that the ratio is the common difference is minus 14. Also in the GP case, I got it is 9, and here it is, if D is minus 14, it will be minus 3, and it will be minus 14, it will be 1. So this is the GP, okay, that we were talking about in the question. Okay. So what is the common ratio here in the GP? This is not asked actually. The one we have already got the answer. I am just checking this, means I am just putting the values and seeing what is the GP, what is the AP, just for understanding, improving the understanding. So here the common ratio is minus 3. Minus 1 by 3, sorry, minus 1 by 3. So if I will multiply minus 1 by 3 to the first term, that is 9, I will get minus 3, and again if I multiply minus 1 by 3, then I will get 1. Okay. So now we have got the answer to this question. So next we are going to learn another concept, that is geometric mean. So what is a geometric mean? Geometric mean of n positive numbers is the nth root of the product of the numbers. Okay. So for example, if I have to find the geometric mean of two numbers, that say A and B. So as I have to find the geometric mean of two numbers, then it will be product of the numbers, that is AB, whole to the power, that is the nth root, that means 1 by 2. As there are two numbers, it will be AB to the power 1 by 2, or you can write as AB square root. Okay. So if there are three numbers A, B, C, so what will be the geometric mean? GM will be A, B, C, product of the numbers, whole to the power 1 by 3. Here 1 by 3 because there are three terms as per the definition. Or you can also write the cube root. Okay. Similarly, if there are four numbers, it is A, B, C, D whole to the power 1 by 4. So for n numbers, say a1, a2, a3 up to an. These are n numbers. So geometric mean, GM of these n numbers equal to a1 into a2 into a3 into a4 up to an whole to the power 1 by n. Okay, so this equation, this thing means this writing, you have to remember this formula. You have to remember that the geometric mean of n numbers a1, a2, a3 up to an is a1 into a2 into a3 up to an whole to the power 1 by n. Okay, geometric mean of n positive numbers is nth root of the product of the numbers. So now we have already learned about geometric progression, geometric mean. In the next class we will learn about the sum of the terms of a geometric geometric progression, and then we will learn about harmonic progression, and then we will complete the chapter. So hope you like it, and please like, share, subscribe to my channel, and also press the bell icon to never miss an update from my channel.